see. Today is Friday, January 6th. We're going to work one example to show the one. It's not even a new thing. It's multiplying fractions. And then I'll explain how this worksheet works because it's a little bit weird. And then I'll tell you what to do on Monday, and then we'll play the Kahoot. So write down that one and only example we'll do together, and then we'll jump into this worksheet. Sine of 4 pi over 3 times cosine of 7 pi over 4. In fact, I'm going to hit pause because I think you can find the sine of 4 pi over 3 and the cosine of 7 pi over 4. And you can probably multiply them together, but we haven't done that together yet, so we'll save that and do that in a moment. So right now, find the sine of 4 pi over 3, the cosine of 7 pi over 4. And if you want to, you can multiply them. If you want to wait for me, that's fine too. So there's our two values. Now the reminder is, how do we multiply fractions? So multiply across. What's the square root of 3 times the square root of 2? Square root of 6. And 2 times 2 is 4. And then don't forget the negative. So negative root 6 over 4. All right, so today is a little bit of that where you know how to find the values, then you multiply the tops, multiply the bottoms. Let me now try to explain how this worksheet works. Some of you started it, and I think you had figured it out. Circuit instructions. We do some of these in calculus more often, just like this process. Start in box 1. Find the answer, and then find that answer in a different box. Seems weird. And then make that box number 2. Find that value, go to the next box, make it box number 3, and so on. And basically, it should all come back around to box number 1. So the sine of pi over 6, that should not require a whole lot of work. JD, what's the sine of pi over 6?
Square root of 3 over 2. Oh wait, that's the y.
It is, yes. You guys better slow down and be careful on Monday. So yes, the sine of pi over 6 is 1/2. This answer doesn't mean the answer to number 1 is that. It means the answer to some other problem is that. So my job is to go find 1/2. Where is it? Oh, there it is. So right-hand column, second one down. So we call this one number 2. So you end up doing all the problems, but you end up with a weird order, and it's kind of multiple choice, and they should all connect and chain back to this first one. We'll see. Cosine of 5 pi over 4. And then how about the cosine of 5 pi over 4?
I don't know.
Well, what quadrant is it in?
Second.
5 over 4? Third. There's your picture.
Oh, it's 2 square root of 2, or square root of 2 over 2. Negative, right?
Good. Negative square root of 2 over 2. And then we go find that answer somewhere. At the bottom. Yes. Not all the way to the bottom, but close. In the middle. So that's number 3. Sine of 11 pi over 3. How am I supposed to do that? What's that? Let's subtract coterminal. Let's subtract 2 pi. So I want the sine of 5 pi over 3. That's a little bit better. Sine of 5 pi over 3. Just keep picking on people here. Oops. Pick on people who are here, not the people who aren't here. Austin, how about the sine of 5 pi over 3? Five over 3?
No.
That's almost 2. So that's quadrant 4, steep angle. Root 3 over 2. Is it positive or negative? It's going down. And then I look for negative root 3 over 2. And that's up toward the top left. So that makes that one number 4. 10 pi over 3. I don't like that. Landry, what do I do with 10 pi over 3? Good. We'll subtract 2 pi. That gets me tangent of 4 pi over 3. Tangents. A little bit harder. I'll slow down the questions here. Hey, Derek, what quadrant is 4 pi over 3 in? Third. And Toby, 4 pi over 3, is that shallow, middle, or steep? Four pi over 3, is that shallow, middle, or steep? We got to do some reviewing here. The 3 is the steep, right? All of the over 3s are the steep angles. So you guys need to go back and take your unit circle on a date to Sonic, right? Go get a tater tot, maybe a chili cheese tater tot with a large Coke, and just spend a few minutes staring at and soaking in, spending quality time with your unit circle. Let's see, y over x ends up being root 3, which would be number, or bottom right. And this is the last one I want to do because we finally got to another one of those multiplication problems. Let's see, sine of 3 pi over 2. Angel, how about the sine of 3 pi over 2? What's that equal to? Where is 3 pi over 2? Like, what quadrant is it in? That's a trick question. So where is 3 pi over 2 on the unit circle? It's not in a quadrant. It's one of the markers. Is it up, down, left, or right? Three pi over 2 is down here. So its coordinates are 0, negative 1. And the y coordinate then would be negative 1. Secant of 14 pi over 3, well, I don't like 14 over 3. So let's subtract 2 pi. That gets us 8 pi over 3. I don't like 8 pi over 3. So what should I do? Subtract it again and get 6 pi, or subtract 6 pi over 3 and get 2 pi over 3. So let's see, that would be second quadrant because it's almost pi. And then secant is the flip of cosine. So what's the secant of 2 pi over 3? What do I get when I flip the cosine?
2. Negative.
Negative 2. And then my answer then is 2 when I multiply those two together. So I go find 2, which is top left, sort of. That's number 6, and so on, and so on, and so on. By the way, this is what's due Monday, up through this. The next page, this is optional. Okay, it's still part of worksheet 5, so I do want to pick up the circuit part of worksheet 5. That's what we were just working on. But the rest of worksheet 5 is optional. Now, based on responses of popsicle sticks, many of you need to do the rest of worksheet 5 to make sure you're comfortable with all of those different things and finding angles, shallow, middle, steep. Some of you got work to do. Others of you are there, you're just cruising through it in your head, but some of you need to finish that out.